Now, in the case of 3C273, what came out of it was a very curious identification. There was at that position a 13th magnitude star.
Which is unbelievably bright.
Unbelievably bright.
A light so powerful it could dwarf our sun 500 trillion times over has just been found. This isn't just a bright star, it's a cosmic phenomenon that defies everything we thought we knew about the universe. What does this mean for the things of space waiting to be uncovered? Let us uncover this mind-blowing discovery and why NASA is preparing to launch a rocket today. This isn't your typical star or even an explosive supernova. No, this object operates on a scale of brightness that's off the charts. It's so intense that it's forced scientists to reconsider the limits of celestial luminosity. The object, observed in a galaxy billions of light years away, has been dubbed the brightest known light source in the universe. To put this into perspective, the light we're seeing today began its path billions of years ago, traveling unimaginable distances to reach Earth. Before we delve into this, it's clear that this discovery changes everything we thought we knew about the universe, and what comes next will completely redefine the limits of possibility. Using advanced telescopes on the ground and in space, astronomers identified this extraordinary phenomenon. These instruments, designed to detect faint signals from the farthest corners of the universe, were practically overwhelmed by the sheer intensity of this light. It's like aiming a flashlight at the sun and expecting to see a difference. The comparison doesn't even come close. So what could possibly shine this brightly? Scientists believe it's a quasar, a cosmic powerhouse fueled by a supermassive black hole. But this isn't just any quasar, it's an extreme outlier, the brightest of its kind ever discovered. Quasars form when black holes pull in enormous amounts of gas and dust. As this material spirals toward the black hole, it heats up and emits tremendous energy, producing a light so intense that it can outshine entire galaxies. This particular quasar, however, is rewriting the rulebook. Its brightness is so extraordinary that some researchers think it might represent an entirely new type of celestial object. Theories are still swirling, but one thing is certain. Whatever this is, it's unlike anything we've seen before. Let's try to grasp the scale of this brightness. The sun, if you were to stare at it directly, is already overwhelming. Multiply that brightness by 500 trillion. It's a level of radiance that defies comprehension. If this object were anywhere near our galaxy, its light would turn night into day and make stars invisible. Its heat and radiation would render Earth uninhabitable, a stark reminder of the universe's raw power. Thankfully, this celestial marvel is safely located billions of light years away. From this vast distance, its light serves as a beacon, offering a glimpse into the extreme forces at play in the cosmos. It's a lighthouse in the dark, reminding us of how much more there is to learn. This discovery is shaking up our understanding of cosmic energy. Scientists are now poring over the data, asking questions that challenge existing models of physics. How can an object shine so brightly without collapsing under its own energy? What conditions could create something so extreme? And what does this mean for our understanding of galaxies and black holes? The implications go beyond science. This discovery is a humbling reminder of our small place in an enormous universe. While we're focused on the challenges of life on Earth, objects like this quasar are out there, far beyond our grasp. They're a testament to the universe's capacity for awe-inspiring phenomena, encouraging us to look beyond ourselves. The discovery wouldn't have been possible without cutting-edge technology. Modern telescopes, equipped with advanced sensors, can capture light billions of years old and billions of times fainter than anything we can see with the naked eye. Instruments like the James Webb Space Telescope and ground-based observatories played a crucial role, combining optical and radio data to reveal this extraordinary light source. This collaboration highlights the importance of global teamwork in science. Observatories from around the world contributed to this discovery, showing what humanity can achieve when we work together. It's a reminder that science isn't just about individual achievements. It's a collective effort to unravel the universe's deepest questions. Now, scientists are racing to learn more about this object. Follow-up observations will focus on its light spectrum, revealing its chemical makeup, temperature, and motion. Researchers are also monitoring its brightness over time, hoping to uncover clues about how it operates. If this object isn't a typical quasar, it could lead to groundbreaking new theories about how the universe works. But why does this matter to us? It's easy to dismiss such discoveries as distant and irrelevant, yet they hold profound significance. Understanding extreme objects like this quasar helps us refine the laws of physics, the very principles that govern everything from atoms to galaxies. This knowledge could lead to technological advancements and even new ways of thinking about energy and life. On a deeper level, discoveries like this inspire curiosity and wonder. They remind us that the universe is far bigger and more complex than we often realize. In a world where we're surrounded by challenges, these glimpses into the cosmos remind us of humanity's capacity for exploration and discovery. This quasar, shining 500 trillion times brighter than the Sun, is a symbol of the universe's boundless potential to surprise us. It challenges our understanding, fuels our imagination, and pushes us to keep searching for answers. As we continue to develop new tools and technologies, who knows what other wonders we'll uncover? For now, this celestial beacon remains a stunning reminder of the universe's extremes. It's a light so powerful that it defies comprehension, illuminating not just the cosmos, but our endless quest for knowledge. And in its brilliance, we find both a challenge and an invitation to keep reaching for the stars. After seeing the brightest light, let's look closer at the hidden forces that shape everything around us. The universe is an enormous, mind-bending space filled with unanswered questions that tease human curiosity. One of the biggest problems is dark matter. Scientists know it's there because it affects how galaxies and stars move. But what is it exactly? Everything we can see, like stars and planets, is only a tiny fraction of the universe. The rest is this invisible stuff called dark matter, and despite all our clever tools, we're still clueless about what it's made of. Then there's dark energy, another invisible force that's even more confusing. Observations show that the universe isn't just expanding, it's doing so faster and faster. This force, which makes up about 70% of the universe, is pushing everything apart. But what is dark energy, and why does it behave the way it does? Scientists have theories, but for now, it's a big question mark. The origins of the universe itself are another topic that keeps everyone scratching their heads. The Big Bang Theory says the universe began from a super-hot, super-dense point about 14 billion years ago. But what triggered this explosion? And what came before it? These questions are so big that even the smartest scientists don't have answers yet. Black holes are equally baffling. These regions in space have gravity so strong that nothing can escape, not even light. While we've captured images of black holes and understand their effects, we have no idea what's happening inside them. Are they gateways to other dimensions, or do they just crush everything into nothingness? And what about life beyond Earth? With billions of stars in just our galaxy and countless galaxies out there, it feels almost certain that other life forms must exist. Yet despite decades of searching, we haven't found any solid proof. Are we truly alone, or are we just looking in the wrong places? Galaxies themselves are a source of endless curiosity. They're massive collections of stars, gas, and dust. But how do they form, and why do they look so different from one another? Some are spirals, some are elliptical, and some are irregular blobs. Scientists are still piecing together the story of how these cosmic neighborhoods come to be. Speaking of mind-bending ideas, there's the theory of the multiverse. This idea suggests our universe might be just one of many, each with its own rules and realities. It sounds like science fiction, but some scientists think it could be real. However, proving it is another story entirely. Time is another question that's hard to wrap your head around. In our daily lives, time moves forward, but physics equations say it can move backward too. Why do we only experience time in one direction? This remains one of the trickiest questions in science. What about the future of the universe? Will it keep expanding forever, or will it collapse back into itself someday? Different theories suggest different outcomes, but no one knows for sure. The ultimate fate of everything is still up in the air. Cosmic rays add to the list of questions. These high-energy particles bombard Earth from space, but where do they come from? Some come from the sun, but others have much higher energy and unknown origins. Understanding them is a challenge that continues to confuse scientists. The uneven spread of matter in the universe is another head-scratcher. Right after the Big Bang, matter seemed evenly distributed. Now we see galaxies and galaxy clusters separated by vast, empty spaces. How did this structure form over billions of years? Researchers are still working on the answer. Star formation might sound straightforward, but it's more complex than you'd think. Stars form when clouds of gas and dust collapse under their own gravity, but the details of how massive stars form remain unclear. These bright giants are essential to the universe, yet their birth process is still full of questions. And then there's the concept of white holes. Unlike black holes, which trap everything, white holes supposedly eject matter and energy, allowing nothing to enter. They're purely theoretical at this point, with no evidence to support their existence, but they're an intriguing idea. From hidden forces to strange events in space, there's so much more the universe has to show us. Gamma-ray bursts are another phenomenon that leaves scientists stumped. These incredibly bright explosions occur in distant galaxies, but what causes them? Some think they're the result of massive stars collapsing, while others suggest they could involve neutron stars or black holes. For now, their true origin remains unknown. Even closer to home, Uranus raises questions with its bizarre tilt. Unlike other planets, it rotates on its side, which makes its seasons and axis unique. Scientists think it might have collided with a massive object long ago, but the exact cause is still uncertain. Saturn's rings are another problem. Made of ice and rock, these stunning rings could be the remnants of a destroyed moon, or leftover material from the planet's formation. Why are they there, and how did they form? We're still figuring it out. The Oort cloud, a theoretical region of icy objects surrounding our solar system, is another unsolved question. It's believed to be the source of long-period comets, but no one has ever observed it directly. Its existence remains an educated guess based on what we've seen so far. Fast radio bursts are another question. These intense flashes of radio waves come from far-off galaxies and last only milliseconds. What produces them? Scientists have theories, from neutron stars to alien technology, but nothing definitive yet. The shortage of lithium in the universe is another problem. Models of the Big Bang predict more lithium than we observe. Why is there less than expected? This discrepancy is still unexplained. Galaxies evolve over billions of years, but the details of this process are still murky. We know dark matter and dark energy play roles, but how exactly do they shape the formation and growth of galaxies? This is a question that continues to challenge scientists. Quasars, which are super bright objects powered by black holes, are another topic of study. They shine with incredible energy, but how do they produce so much light? Understanding the mechanics of quasars is a work in progress. The imbalance between matter and antimatter is a major question. The Big Bang should have created equal amounts of both, but the universe is overwhelmingly made of matter. Where did the antimatter go? This remains one of physics' biggest questions. Neutron stars are another fascinating subject. These dense remnants of supernova explosions contain matter packed so tightly that a sugar cube-sized amount would weigh billions of tons. What happens to matter under such extreme conditions? Scientists are still investigating. Planet formation is another area of active research. While we have a general idea of how planets form around young stars, the details, especially for massive gas giants, are still unclear. How do these planetary giants gather so much material? Exoplanets, or planets around other stars, raise countless questions. Thousands have been discovered, but understanding their atmospheres, compositions, and potential for life is still in its infancy. Are there Earth-like worlds out there? The cosmic microwave background, the faint afterglow of the Big Bang, has been studied extensively, but small anomalies within it remain unexplained. What do these irregularities mean for our understanding of the universe's early days? Large-scale structures like galaxy filaments and voids are another problem. How did these massive structures form, and what forces shaped them? Cosmologists are still piecing together the answers. Time dilation, as predicted by Einstein's theory of relativity, is a real and measurable effect, especially near strong gravitational fields. But what does this mean for the nature of time itself? This question keeps physicists busy. Wormholes or shortcuts through space-time are another tantalizing idea. While they're allowed by the equations of general relativity, no evidence for their existence has been found. Could they ever be real, and could they be used for travel? Finally, the singularity at the heart of a black hole is one of the most profound questions in physics. This is a point where densities become infinite, and our current understanding of physics breaks down. What happens in these extreme conditions? The answers remain hidden, much like the singularities themselves. Now that we've seen strange events, let's go back to how everything started, from almost nothing to the whole universe. The Big Bang Theory is like the story of how everything we see today started out as almost nothing. Imagine the entire universe squished into a spot smaller than a pinhead. About 13.8 billion years ago, something incredible happened. This tiny, unimaginably dense and hot spot began to expand. It wasn't a bang like an explosion, but more of a sudden swelling, and it hasn't stopped growing since. This expansion shaped the stars, galaxies, and planets that fill the vastness of space today. In the early 20th century, scientists started piecing together the evidence for this big beginning. Georges Lemaitre, a Belgian priest and physicist, had the wild idea that the universe started from a primeval atom. Then Edwin Hubble looked through his telescope and noticed that galaxies were moving away from us. The farther away they were, the faster they seemed to be going. This discovery of the expanding universe gave solid backing to the idea that everything had a starting point. At the very start, the universe was no bigger than a tiny dot, a place so dense and hot that the normal rules of physics didn't seem to work. Scientists call this a singularity, and it's hard to fully understand what it was like. As it expanded, things started cooling down. Tiny particles like protons, neutrons, and electrons came into being. These little building blocks later joined together to form simple atoms like hydrogen and helium, the lightest and most basic elements. Over time, gravity got to work, pulling these atoms together to form massive clouds of gas. Inside these clouds, denser pockets collapsed to form the first stars and galaxies. These early stars were like cosmic factories, fusing hydrogen and helium to create heavier elements like carbon and oxygen. Without these processes, the universe wouldn't have the ingredients for planets or life. A key piece of evidence for the Big Bang Theory is a faint glow that fills the universe, called the cosmic microwave background radiation. Discovered in 1965, this radiation is like an echo of the universe's early days. Back then, about 380,000 years after the beginning, the universe had cooled enough for light to travel freely. That light has been stretched over billions of years as the universe expanded, leaving behind this faint glow that scientists can still detect today. Another clue comes from the amounts of hydrogen, helium, and a little bit of lithium that we see in the universe. These elements were formed in the first few minutes after the Big Bang in a process called nucleosynthesis. The amounts match what scientists predicted would happen if the universe started from a hot, dense state and cooled over time. This agreement between prediction and observation is another reason scientists are confident in the Big Bang theory. We also have the redshift of galaxies, which is like a cosmic Doppler effect. When galaxies move away from us, the light they emit stretches out, shifting to the red part of the spectrum. The farther away a galaxy is, the more its light is redshifted. This pattern supports the idea that the universe is expanding, with everything moving away from a common starting point. But even with all this evidence, there's still a lot we don't know. For one thing, most of the universe is made up of stuff we can't see or understand: dark matter and dark energy. Together, they make up about 95% of the universe. Dark matter seems to hold galaxies together, while dark energy drives the universe's expansion. Yet, despite their importance, we know almost nothing about what they really are. Another big question involves the very first moments after the Big Bang. Scientists call this the Planck epoch, the first fraction of a second after everything began. During this time, the universe was so hot and dense that the normal laws of physics break down. To truly understand what happened, we'd need a theory that combines quantum mechanics and general relativity, but we don't have that yet. What's clear is that the Big Bang theory has revolutionized how we think about the universe. It shows us that everything, from the smallest particle to the largest galaxy, came from the same incredible event. It's a humbling thought, one that connects us to the cosmos in a way that's both awe-inspiring and deeply strange. And while there's still so much to learn, each discovery brings us a little closer to understanding our place in the grand scheme of things. Is this object a natural wonder of the universe, or could it be something created by forces we don't yet understand? Share your thoughts and remember to like and subscribe for more.